In this class, we're going to go over questions on velocity time graph. Okay, let's start with the first question. We are given this graph. This graph represents the velocity time graph of a body. We are asked to calculate the distance covered in the first 20 seconds. Okay, don't forget, in our previous class, I told you that when we talk about distance on a velocity time graph, we are referring to the area of the graph. You understand? Area of the shape on the graph gives the distance of the body that undergoes such velocity time graph. Now, if you look at this graph, you will see that the area of the whole graph is what? Is a trapezium. You understand? The shape of the whole graph is a trapezium. This is how the shape look like. You understand? But we don't need the area. Okay, let me just put it. Area is equals to distance. When you are dealing with velocity time graph, just pay attention to this. Area of the shape is equals to the distance of the body. You understand? Okay. Now, the total area, the area of this, the area that we have on this velocity time graph is a trapezium, but we are not asked to determine the total distance. We are asked to calculate the distance that the body covered in the first 20 seconds. You understand? And the first 20 seconds is from this point to this point. Is from this point to this point. You understand? Because the time is along this is the time and this is the velocity. Okay. Now the first 20 seconds is from this point to this point. So the shape now becomes like this. You understand? Let me call this point A, B, C, D, E. You understand? Let us call this F. Normally, the total shape is what? A trapezium, which is A. Okay, no, which is A, B. Okay, we have something like this: A, B, C. We have D, we have E, and we have F. But because we are only interested in the distance that the body covered in the first 20 seconds, so this is the shape that we need: A, B, C, D, and E. You understand? This is the shape that we need. Hello? Because this is the first 20 seconds. Now, having identified the shape, the next step is that let us label the shape. You understand? So from this point to this point is 20. So from A to E is what? Is 20. From C to E is what? Hello, pay attention. From C to E, this distance that you see here is, just trace it to the velocity side. That is 4. So from C to E it is 4. Now from B to C, which is the shape from this point to this point, please pay attention. It's simple. Okay, you see what I'm doing is that we are asked to calculate the total distance that the body traveled in the first 20 seconds. The time taken for the whole journey is 25 seconds, but we are only interested in the total distance that it traveled in the first 20 seconds. So now the first 20 seconds is from this point to this point, which is what? 20. So the shape along the first 20 seconds is also a trapezium. You understand? That is why I dragged it out. You understand? Now the distance from this point to this point, which is from A to E, is what? 20. You understand? That is the distance from this point to this point. That is 20. And the distance from this point to this point, that is 4. Because when you trace it from this point to this point, you trace it to the velocity side. The velocity is represented along the y-axis. You understand? Hello? The velocity is represented along the y-axis. So if you trace it to the velocity side, you are going to discover that the corresponding value of the velocity is what? Is 4. So from this point to this point, which is E to C, is 4. Now, the next side that I need is what? From this point to this point, which is BC. The distance of BC is what? 20 minus 10. You understand? 20 minus 10 is what? 10. So the distance from this point to this point is 10. I'm going to show you how I got it. Do you know that we have 10 here, we're going to have 10 here, we have 20 here, we're going to have 20 here. Now 20 minus 10 is what? 10. Do you understand? That is how I got the distance between B and C. Okay? Now I'm going to have 10 in this place. Now I've gotten all the size that I need to determine the distance that the body traveled in the first 20 seconds. All I need to do is that just take the area of this trapezium. You understand? And the area of the trapezium is given by this formula. Area is equals to half A plus B multiplied by height. A and B are the parallel side of the trapezium that can never meet. So the first parallel side is what? Is 20. So I'm going to have area is equals to 1 over 2A. A is 20, then B is 10. You understand? When we talk about parallel, those sides can never meet. You understand? Parallel lines, do you remember in your geometry? Parallel lines, they can never meet. So here we have 20 plus 10. 20 plus 10 multiplied by height. In this case, height is 4. So the area is equals to 1 over 2 multiplied by 30. 20 plus 10 is 30. 30 multiplied by 4. Here I'm going to have 15 because 30 divided by 2 is what? Is 15. 15 times 4 is what? 60. So the area is equals to 15 multiplied by 4 is 60. So I'm going to have 60 meters. So the area that the distance, now you change it now. The distance is equals to S. S is equals to 60 meters, which is the distance that the body covered in 20 seconds. Do you understand? Okay, so that is the solution to that question. Now let's proceed to the second question. Okay. Okay, the figure shows the velocity time graph of a car which starts from rest and is accelerated uniformly at the rate of 3 meters per second squared for 5 seconds. It attains a velocity which is maintained for 1 minute. The car is then brought to rest by a uniform retardation after another 3 seconds. Calculate the total distance covered by the car. Now, they gave us this velocity. The velocity is not labeled, you know, they didn't represent, they just gave us the parameters, they needed information that we need to, they give us a typical representation of how the velocity time graph will look like. So we are asked to calculate the distance. Now, let's start our solution. Please, I want you to pay attention, okay? All you have to do is just be attentive. Let's start with the first parameter that we're given. This figure shows the velocity time graph of a car which starts from rest. Now, from rest simply means it starts from this point and it accelerates uniformly at the rate of 3 meters per second squared for 5 seconds. So, when a car accelerates, the velocity increases. You understand? Hello? Acceleration tells us how fast the velocity of an object is changing. Okay? So, when a car accelerates, the velocity of that car changes from 0 to it has a significant velocity. So when this car accelerates for 3 meters per second squared, it attains a velocity. The velocity we don't know, but the velocity should be here. You understand? It attains this velocity. This is the velocity that is attained. We don't know it. Let us represent it as VF. Okay? Now, that is the time that is used to accelerate from rest is what? Is 5 seconds. So here is going to be 5. Okay. Now, the question says it attains a velocity which is maintained for 1 minute. Now, our time is represented in seconds, so we are going to use seconds. Okay. Change 1 minute to seconds. 1 minute is equivalent to 60 seconds. You understand? So it maintains that velocity for another 60 seconds. So that means that from this point to this point, the time is 60 seconds. So let's just trace it. Now, from this point to this point, the time is 60 seconds. That means that from this point to this point, the time will be what? 65. Hello? From this point to this point is 5. From this point to this point is what? 60 seconds. That means that from this point to this point, the time will be 65 seconds. Do you understand? You must learn how to interpret question, okay? That's what I'm trying to explain. That's what I'm trying to do, okay? You see, it accelerates at the rate of 3 meters per second squared for 5 seconds. That is the representation here. It attains the velocity. This is the velocity. Now, it maintains this velocity for another 1 second. That is what? 60. Another 1 minute. That is what? 60 seconds. So, that means that from this point to this point is what? 60 seconds. Now, if from this point to this point is 60 seconds, and you know that from this point to this point is 5 seconds, that means that the total distance from this point to this point is what? 60 plus 5. That is 65 seconds. You understand? So let me erase. I'm coming. Let me erase this. Okay, so from this point to this point is 65 seconds. Now, let's proceed to the with the question. The car then is brought to rest by a uniform retardation for another 3 seconds. Don't forget, in our previous class I told you retardation is negative acceleration. It is the kind of acceleration that brings the motion of an object to rest. You understand? Okay, so when it retards, after undergoing retardation for another 3 seconds, it is brought to rest. So that means that the seconds, the time taken from this point to this point is what? Is 3 seconds. So if this is 3 seconds, that means that from this point to this point is what? 65 plus 3. That means I'm going to have 68 seconds. You understand? Okay, I'm just trying to teach you how to how you are going to get the parameters that you need to calculate the total distance, because if you didn't have all these parameters, it's very, very important for you to calculate the total distance. And this is a JAM question. You understand? It's a UTME past exam question. Okay, so now we are done with the interpretation. You understand? Now, how do we calculate the total distance? The distance on the velocity time graph is equivalent to the area of the velocity time graph. You understand? Now, if you look at this shape, what area do you see? What is the name of the area that we have on this velocity time graph? The area is, what's the shape rather? The shape is trapezium, you understand? So, let me just label it A, B, C, D, E, F. You understand? Okay? Now, and the area of a trapezium is given by this formula. Area is equals to half A plus B multiplied by H. You understand? And I told you height on a velocity time graph is the velocity. You understand? Because the velocity is measured along the y-axis. You understand? The velocity is measured along the y-axis. So the height on the velocity time graph is the velocity. All you have to do is just to trace that point to the velocity, which is the y-axis. You are going to get the corresponding value. That corresponding value there is the height. Now, we know that A and B are the parallel side of the trapezium. Let me bring it out. Okay. This is the shape that we have. Okay. Look. This is A. This is B. This is C. This is D, this is E, and this is F. You understand? From this point to this point is what? 68. Okay. Now, from this point to this point is what? 60. Okay. Now, this is A. Hello. This is A. This is B. Now, we need the H. The H is the velocity. The velocity that we need is VF. You understand? The height is the velocity. The velocity that is attained, that velocity is what we need. Now, how do we determine the velocity? Because if you don't know the velocity, we cannot determine the area. You understand? Because area is 1/2 multiplied by A plus B multiplied by height, and height is the velocity. So we need the value of the velocity. Now, we are given an information in that question that the body accelerates from rest as an acceleration of what? 3 meters per second squared. So now acceleration is equals to 3 meters per second squared. Now when it accelerates, it attains the velocity. That velocity we need to determine it. That velocity is Vf. Because from our previous class you know that acceleration is change in velocity over time. You understand? So here acceleration, which is 3 meters per second squared, is equals to change in velocity, that is V all over T. Hello? You just have to pay attention. What I want to do is that I need to determine the velocity, okay? The velocity that it attained, the velocity that the body attained when it accelerates at the rate of 3 meters per second squared. And acceleration is what? Velocity over time. So here I'm going to have Vf all over time. Now, 3 is equals to Vf all over T. T is 5 because it accelerates at 3 meters per second squared. It attains the velocity. The time that it's used to accelerate at that velocity, the time that it's used to undergo acceleration is what? Is 5 seconds. You understand? If you pay attention to the question, you are going to understand what I'm doing. Okay? So here I'm going to have 3 here. So all you have to do now is to cross multiply. Oh, it is 5. So I'm going to have 5 here. So Vf is equals to 5 multiplied by 3. The velocity that it attained is what? 15 meter per second squared. Okay? Oh, sorry. 15 meter per second. The velocity is in meter per second. Now, we cannot determine the area, I mean the distance. So the distance is equals to 1 over 2 multiplied by 68 plus 60 multiplied by 15. I'm very sure you understand how I got this. Look, the first parallel side is 68, the second is 60. The height, which is the velocity, is 15. That's how I got this, okay? So S is equals to 1 over 2 multiplied by 60 plus 68. That is 128. 128 multiplied by 15. Okay? Now, 128 divided by 2. That is 64. Okay? So here we're going to have S. Okay? S is equals to 64 multiplied by 15. That is S is equals to 960. That is 960 meter. Do you understand? If you didn't understand, you have to listen to the explanation again. Okay? So that is how to solve question on velocity time graph. If you need more question on velocity time graph, check the playlist of this topic. Check the playlist on this channel. Click on this channel, check playlist, then scroll to velocity time graph. You're going to see the solution. I've done many questions on this. Just practice those questions. Okay, so that will be all for this class. If you have any question regarding what we've learned in this class, let me know in the comment section. And if you've learned anything and you want to be part of this channel, subscribe, and don't forget to like and share the video. Okay, see you in the next class.